Morning guys, just wanted to give you a quick video intro to our quadratic functions. Again, we'll look at this in more detail when we come back after the midterm break, but as I said, we've done pretty much everything we can do on a linear function, and it's not something that comes up that often for higher level students, so I kind of want to move on to the next section today. Our quadratic functions, as I said, it works exactly the same way. We're going to have a function with a quadratic term now instead of a linear term. So on some of them you were doing, say maybe the function is 3x minus 5. Instead of that, we're going to have a quadratic term. So it's going to have an x squared in the function. And that's the only difference between what we've done previously and what we're doing here. From that there, you use the function. We have input values, which we sub in as our x values. We put them into the function. We solve for the output value, which is going to be represented on the y-axis, and then we plot our points and we draw our curve in this case. So you guys did linear functions where we had straight lines as our for the result that our graph was drawn out and it gave us a straight line. With quadratic functions, we have a curve, and you can see the two examples here in the bottom right hand corner of the slide. You've got when we've got a positive x squared, which you can see here. Oh, sorry, I'm looking at the wrong ones. When we have a positive value here, we'll end up with a curve that goes like a U shape or a smile. So we think positive, we smile. And if we go negative, we frown, or we have the N shape. Okay, so again, the exact same things you're doing. Input output table, plot your points, graph your quadratic equation. The only difference here, remember we discussed with a linear function, we talked about 3 points would suffice. In this case here, you can see it here, we have to do all of the whole number of values in the domain must be used. So, you know, when we were given something and it looked like minus 3 is less than or equal to x, which is less than or equal to 3. And I said you could use any 3 points within that range between minus 3 and 3. And remember, the examples that we gave, we usually give your extremes. So minus 3, 3, and 0. They were the 3 points that I had suggested to do. In this case, we can't do that anymore. Because we have a curve, we have to plot every single point within the domain. So in this case, as I said here, if you were doing minus 3 up as far as 3, we'd have to do minus 3, minus 2, minus 1, 0, 1, 2, 3. So you got 7 points that you'd have to put into the function, and you'd have to put them all into your input-output table. So the example question here, again, these are all from your textbook, just to show you. We have our function here. You can see it now. It's quadratic because it's got an x squared, and it's negative because we've got our minus there. So before we even do any work, I'm expecting my graph to look like an N shape or a frown. Okay, we can see it there. It's minus 3x squared minus 2x plus 3, and we've got the domain minus 2 up as far as 2. As it says here, we have to use all the whole number values from minus 2 up to 2. So that's why we have them here. Minus 2, minus 1, 0, 1, and 2. We substitute them into the function. So you can see we're subbing in minus 3x squared and minus 2x plus 3. And again, you're practicing your algebra there. Should be no problem T. And we end up with our output, or our y value. Minus 2 and 5 in this case are our first couple, or our first pair of plots for a point. And you can see that's minus 2, minus 5. Remember, x-axis is our horizontal, y-axis is our vertical. So we fill in the full table, you end up with your couples, you plot those points, and then we draw the curve. Okay, now remember, the thing to also keep in mind here, we should draw a curve. Okay, it will be it's not a straight line. Okay, so we don't use a ruler to draw a straight line, say from straight line, straight line, straight line, straight line. It's not like that. Okay, it has to be a curve, so a sweep. So we have to do that carefully in our diagrams. So just to keep that in mind, you're not joining them and it's not going to look like a point on a mountain, say, for example. It has to be a sweep or a curve. It's called a parabola. That's the name for it. All right. So, as I said here, and as we just mentioned, common mistakes, things that we usually get wrong when you're drawing them. Number one, not enough points. Remember, when we were doing linear, we could say 3 was enough. When it's a quadratic, we have to say all of the domain has to be used. Second one there, drawing a line instead of a curve. As I just mentioned, you can see straight line, straight line, straight line, straight line, straight line. Not correct. What we need to do is that we need to draw a curve. So you can imagine the curve would go down and back up like that in this instance. And then finally, points are obviously incorrect. We don't form a parabolic. Okay, remember I said that a second ago? A parabola is our kind of sweeping curve like those. And these points are obviously plotted incorrect. You would expect that point should be somewhere down here maybe. And that would give you a nice parabola as we've discussed. Oh, let's go again, sorry. So something like that. Okay, so you can see that that point is probably been plotted wrong for whatever reason. So from there then, I've got an example question done for you. I'll just watch this and then you guys are going to be able to try these. Then when we come back from midterm break, we might re-watch this video after midterm break also. So you've got the graph, again, a minus quadratic function. Some of the inputs are done for us already. So we've got 2 of them done. I've done all the rest there. So I've done -1, 0, 2, 3, and 4. Okay, and you can see part A is our input-output table is done then essentially. We have our points will go in here, and let's see, sorry, that's going to be 2. That's going to be 5. That's going to be... Sorry, I'm looking at the wrong ones. 2, 5, 5, yeah, sorry, my mistake. 2 and -3. So we can see what's happening. X values are going up. So we're going from left to right on the x-axis. But what's happening with the y values? They're starting low. They're starting in negative. So you're going to start down here. They're slowly getting higher. And then they drop back down again. -3, 2, 5, 6, 5, 2, -3. So we ended up with a curve that's going to look something like that, imagine. So we have our inputs and outputs now. So that means we have our couples. And we're going to plot them on the graph. So you've got -2, -3, our first one here. -2, -3. So I go across on my x, I go up and down on my y. -2, -3 is there. First point. -1, -1, 2, sorry. -1, I go across on the x, up on the y is there. 0, 5. So I'm going to go, it's going to be on the y-axis. It's going to be that point there, 0, 5. 1, 6 is up here, right at the top. Just about get it there, okay. And it'll be even a bit more accurate for you. I can't do it with my finger, lads. But it's just a little bit higher than that, but you're going to see exactly now. 2, 5 is there. 3, 2 is there. And then 4 -3 is back down here. So we've now plotted those points and we have to draw our curve. So again, we're going to do a parabola. So a sweep that's going to go through all those points. And again, this isn't perfect, but you get the idea. Let's try that once more to see. So you're going to have one fluid motion, and it will go through each of those points and give you a curve like that. So that's the way we draw it. So we take our time, and we'll be able to give that a go with one question that I'm asking you to do today. Thank you very much.